Welcome back to Chem Past Papers. In this video, we are solving IGCSE Paper 4, Variant 2, October-November 2023. This is part 1, covering questions 1 to 3. I'll show you the exact mark scheme answers, plus exam tips to avoid common mistakes. Let's start. Question 1. Table 1.1 gives the electronic configurations of some atoms and ions A to G. These are the electronic configurations. Answer the following questions about A to G. Each letter may be used once, more than once, or not at all. State which of the atoms or ions A to G could be a noble gas atom. So what we are going to look at is electronic configuration that has a complete shell, because we know our noble gases, they have a complete electronic configuration. So here our answer should be B. The electronic configuration is 2,8. Next, an atom of an element in group 6. Now, we know that the number of electrons in the outer shell determines the group that an element belongs to. So here, we are looking at an element with 6 electrons in the outer shell, which is F. So our answer is this. Next, an atom with an atomic number of 14. Now, atomic number for a neutral atom is the proton number, and the proton number is equal to the number of electrons. So since this is an electronic configuration, that means you are looking for an atom with 14 electrons, because number of electrons is equal to the number of protons in a neutral atom. So which one has 14? Has to be 2 plus 8 is 10 plus 4, 14. So our answer is D. Next, atoms from the same group. Now, number of electrons in the outer shell determines the group. So we're looking for atoms that have the same number of electrons in their outer shell. So if you look at this, we have A and E having 5 electrons in the outer shell. So that means A and E are in the same group, which is group 5. So therefore, our answer is A and E. Next, a halogen atom. Now, halogen is another name for group 7 element. So we are looking at group 7. And how do you know which one belongs to group 7? We check the number of electrons they have in the outer shell. As you can see it here, element G has 7 electrons in the outer shell. So that means element G is a halogen. Next question. An atom of an element which is a good conductor of electricity. So we know that metals are good conductor of electricity. So we are going to look at an atom that belongs to group 1 or group 2, because they are metals and they conduct electricity. So how do we know? We check their number of electrons in the outer shell. Look at this, C is in group 2. We don't have any member that is in group 1. So C is in group 2, and group 2 are metals. So therefore, C is our answer. A stable ion of a group 5 element. Now you need to take note of this. We're talking about ion here. So that means we are looking at a group 5 element that has become an ion. We're not looking for group 5 element. We're looking for a group 5 element that becomes an ion. So we're looking for 2,5 that has become stable. Now, if a group 5 element becomes stable, it will gain 3 electrons and it will become 2,8. So that means we are looking for 2,8 or 2,8,8. And from here, the element with 2,8 is B. So our answer is B, because showing us that group 5 can be the electronic configuration of a group 5 element that has become an ion by gaining 3 electrons. So our answer therefore is B. Next, an atom that forms an ion with a charge 2 minus. Now, this charge simply means it has gained 2 electrons. So we are looking at an atom that gained 2 electrons. So for an atom that gains 2 electrons, that means it must have 6 electrons in the outer shell in order to gain 2 electrons to be stable. So that means here we are looking for the element that has 6 electrons in the outer shell. And that answer is F. F has 6 electrons in the outer shell. It gains 2 electrons, become 2,8,8, and the charge is going to be 2 minus. So therefore, our answer is F. Next question. Cobalt and copper are transition elements. Copper has 2 naturally occurring isotopes. We have copper 63 and copper 65. Cobalt has only 1 naturally occurring isotope, which is cobalt 59. Complete table 2.1 to show the number of protons, neutrons, and electrons in the cobalt 59 atom and the copper 65 ion. So please take note here, there are 2 different atoms here. So don't make mistake of thinking it is cobalt and cobalt or copper and copper. So let's start with cobalt. Protons. Number of protons is equal to the atomic number. So what we'll do is here is to check our periodic table to look at the atomic number of cobalt. That will give us the number of protons. So this is our periodic table. So we look at where is cobalt. Cobalt is here. We look at it, the atomic number is 27. So since cobalt here is neutral atom, doesn't have any charge, that means number of protons is going to be 27. Number of neutrons. The number of neutrons is going to be 59 minus 27. Why? Because this 59 is the atomic number, and the atomic number is the number of protons and neutrons in the nucleus of an atom. So since the proton is 27, that means our number of neutrons is going to be 59 minus 27, which is going to give us 32. Next is number of electrons. The number of electrons, since cobalt is a neutral atom, doesn't have negative or positive charge, that means the number of protons is equal to the number of electrons. So that means the number of electrons for cobalt is also 27. Then we move to copper. Number of protons of copper is still going to be the same thing as the atomic number of copper. So let's check the atomic number of copper from the periodic table. On the periodic table, the atomic number of copper is 29. So therefore, the number of protons is 29. Then the number of neutrons is still going to be the same thing we did here. 65 mass number minus 29, which is the proton number. This is going to give us 36. Then now, the number of electrons. Now, in this case, we have a charge here. This 2 plus means it has lost 2 electrons. So the number of protons and electrons here is not the same because it has lost 2 electrons. So therefore, our number of electrons is going to be 29 minus 2, which is going to be 27. So this is the answer. Next, table 2.2 shows the relative abundance of the two naturally occurring isotopes of copper. Look at it. We calculate the relative atomic mass of copper to 1 decimal place. Very important, 1 decimal place. So to calculate the relative atomic mass, we multiply 63 by 70 plus 65 multiplied by 30 divided by 100. So let's do that. So when you press your calculator, this is going to give us, don't forget, I told that we leave our answer in 1 decimal place, so do not approximate to 64. Leave it at 63.6. So that's how you solve it. Don't forget, mass multiplied by percentage abundance plus mass multiplied by percentage abundance divided by 100. Next question. One physical properties of transition elements such as copper and cobalt is that they are hard. Other metals such as lithium are softer. State 2 other physical properties of copper and cobalt which are significantly different from lithium. So we are looking at the physical properties of transition metal that are different from that of alkali metals, that is group 1 elements, group 1 metals. So the answer is going to be high density, high melting point. Please take note that we are asked for physical properties. So don't use chemical properties such as act as catalyst, variable oxidation state, and so on and so forth. This is physical properties. So in physical properties, transition metals have high density than group 1 element, and also they have high melting point and boiling point. Next question. Both copper and cobalt can form colored compounds. Some of these compounds contain water of crystallization. Define the term water of crystallization. So water of crystallization is water molecules chemically combined within a crystal lattice. So you have hydrated copper 2 sulfate, hydrated cobalt 2 chloride. That means they contain water molecules. So we call that water of crystallization. Next, state the color and formula of hydrated cobalt 2 chloride crystals. So the color of hydrated cobalt 2 chloride crystals is pink. And then this is the formula. This is the water of crystallization we're talking about. So don't forget the color is pink and this is the formula. We use cobalt 2 chloride to test for water. Changes color from blue to pink to indicate that water is present. I said take note of that. Next question. State the color change seen when a few drops of water are added to anhydrous copper 2 sulfate. So like I stated earlier, copper 2 chloride is used for test of water as well as copper 2 sulfate. So the color change is going to be white to blue. So when it is anhydrous copper 2 sulfate, the color is white. When water is added, it becomes hydrated copper 2 sulfate and the color will change to blue. State how this color change can be reversed. The simple answer is by heating, because you added water. So when you heat, the water will go and it will change color, because what makes it blue is the addition of the water. So when you heat it, water evaporates and then it becomes anhydrous again. Question 3. Iron is manufactured in a blast furnace. Three of the starting materials added to blast furnace are coke, iron ore, and limestone. Name the other starting material added to the blast furnace. So take no order. We are not expected to mention these ones that have been mentioned. What other materials do we add at the start of the manufacture of iron in a blast furnace? The answer is simply hot air. So hot air is one of the starting material that is added. Next question. The source of the iron in the blast furnace is iron 3 oxide. Iron 3 oxide is found in iron ore. Name the main ore of iron which contains iron 3 oxide. So the main ore of iron that contains iron 3 oxide is hematite. So you need to remember all these things. The starting materials, the ore, the equation of the reaction for both extraction of iron and for extraction of aluminium. Next question. The iron in iron 3 oxide is reduced by reaction with carbon monoxide. The unbalanced symbol equation is shown. Complete the equation. So this one is balancing chemical equation. Now how do we balance this chemical equation? We count the number of atoms we have on each side, make sure they are balanced. So let's start with our iron. Iron is 2 here, but iron is 1 here. So we balance it, we write 2 here. So we have 4 oxygen here, 3 here plus 1, 4. And here we have 2, so we have to make this one 4. So make this to become 2. So our oxygen is 4, but then our carbon has become 2. So we need to make this carbon 2. If you add 2 here, carbon has become 2 also, but then our oxygen has increased. Oxygen is no longer equal. Oxygen becomes 3 plus 2, which is 5, and here is 4. So we need to look for a way to balance that. What we're going to do is to increase the number of oxygen on both sides by 1, so that we can show that it's balanced. So let's change it to 3, 3, from 2, 2 to 3, 3, and see. Now when you add 3, 3, let's see our oxygen becomes 6 here. Now oxygen also is 6. Our carbon is 3, our carbon is 3. So the equation is balanced now. Next question. State the change in oxidation number of iron in the reaction in 2 here. So the changes in oxidation is from plus 3 to 0. How do we know that? This is iron 3 oxide. The 3 signifies the oxidation number. So that's why we say it's plus 3. When it moves here, it becomes only iron. So this is a monoatomic atom. For a monoatomic atom, the oxidation number is 0. So that is why we have here 0. So from plus 3 to 0. Explain how the change of oxidation number shows that iron has been reduced. If you look at it, there's decrease in oxidation number from 3 to 0. So decrease in oxidation number shows that what reduction took place. That is how we know that iron has been reduced. Next question. The major impurity in iron ore is silicon 4 oxide. Limestone is added to the blast furnace to remove this impurity. Write 2 symbol equations to show how silicon 4 oxide is removed. For each equation, state the type of chemical reaction that takes place. So the first equation that is going to take place is the composition of the calcium carbonate that is added, which is limestone. Limestone is calcium carbonate. So let's write the equation for that. So our calcium carbonate will decompose to calcium oxide and carbon dioxide. Now, what type of chemical reaction is that? So already you have already stated this is a decomposition reaction, but it is a thermal decomposition reaction because heat is involved. Decomposition means breaking down. So it is the heat that breaks it down into calcium oxide and carbon dioxide. So the type of chemical reaction is equation 2. Now in our equation 2, the calcium oxide will react with the silicon 4 oxide to give us our slag, which is calcium silicate. So let's write the equation for that. So this is the equation. We have our silicon 4 oxide plus calcium oxide to give us calcium silicate. Now what type of reaction is that? Now you know that in types of oxide, when a metal forms an oxide, the oxide is alkaline. When non-metal forms oxide, the oxide is acidic. That means this silicon 4 oxide is an acidic oxide, and then calcium oxide is a basic oxide. So that means this is an acid-base reaction. So that will be our answer. Next question. Iron is converted to steel by mixing it with carbon and other elements. State the time given to a substance which is a mixture of a metal and other elements. So this is very simple. The answer is alloy. Next question. Name one other element other than carbon mixed with iron in the making of stainless steel. So the answer is nickel or chromium. These are the elements that are mixed with carbon in making of an alloy called stainless steel. Next question. Preventing the rusting of steel is important. State the chemical name of rust. The chemical name of rust is hydrated iron 3 oxide. Next question. Steel can be coated with zinc to prevent rusting. This provides both a barrier method and a sacrificial protection. State the term used for coating steel with zinc. The term used for coating steel with zinc is galvanizing. Next question. Describe another barrier method for preventing rusting. So another barrier method for preventing rusting is painting, or you can write greasing or plastic coating. Any of these is correct because they can be used to prevent rusting. Explain how zinc provides sacrificial protection. Sacrifice itself for iron. That's the end of part 1, covering questions 1 to 3. Part 2, covering question 4 to 6 is linked in the description. If this helped, don't forget to like, subscribe, and share. I'll see you in the next video.